an answer? Did anybody get the area? Somebody talking?
No, miss.
Okay. Nobody got it. All right. So what do they want me to find? They want me to find the area. This is a sector, right? We know how to find area of a sector. Can anybody tell me what's the formula? This angle is in radian. So what's the formula to find the area of the sector?
Half r squared theta.
Okay, good job. So this is the formula we know to find the area of a sector when given an angle in radian. Okay, so you might think, all right, this is a simple question. Let me just substitute the values, whatever. There's a problem. Yeah, I have my value for theta, pi on 6. But what is the value for my radius? What's the value of the radius? We don't know. So what does that mean? We need to find the value of the radius. But how exactly are we going to do that? Well, let's write down all the information that they gave. They told us that the parameter, they told us the angle for one is x. So theta is pi on 6. And they also told us that the parameter of this sector is given as 5 on 6 by 12 plus pi. So when they say parameter, you mean sum of this side plus this arc length plus, right? So we're given that the parameter P is this 5 on 6 by 12 plus pi. We don't want to find parameter. We're interested in finding the area. But we can't find the area. Why? Because we don't have a value for r. We need to find our value for r. That's the only way we'll be able to find the area of the sector. So how exactly do we go about finding this value? Well, if I know that my parameter is 5 on 6, let me just write it again. 5 on 6 by 12 plus pi. And I said that the parameter is the sum of this side plus this arc length plus this other side. I know that these two, that's the radii. So this is the radius, this is also the radius. How do I know that? Because this is a sector. For the sectors, see these two lengths, it's always the radius, right? You might be wondering why is that? Let me just show you real quick. So see, this is a sector. This is the center of my circle. This is a radius. How do we know that it's a radius? It connects the center and the circumference of the circle. This is also a radius. This entire thing in blue is known as a sector. So I went through this on Tuesday, right? So you see for sectors, this length and this length, it's the radius, right? So for this sector, this length here is radius, and this is called the arc length, or the length of the arc. We know that, right? So let me just put L to represent the length of the arc. Find the parameter, we need the sum of R plus L plus R. So let me write that. R plus L plus R. That's the definition of parameter, right? Everybody following so far?
Yes, miss.
All right.
Yes, miss.
5 on 6, that's my parameter. Told me this is the parameter. Instead of writing R plus R, I know R plus R is 2R. L. L is the length of this arc. I wasn't given the length of the arc, but I do know a formula to find the length of the arc. Find the length of the arc when my angle is in radians. It's L is equal to r theta. So instead of putting 2r plus L in this case, I can replace the L with 2r plus r theta. Follow? So far?
Yes, miss. Yes, miss. You replace it. Yes, miss.
Okay. I like that. Okay. Let me use the oh, right. Let me use this screen. Right. So 5 on 6, 12 plus pi is equal to 2r plus r times theta. We already know that theta is pi on 6, right? So r is pi on 6. All we need to do is find our value for r. That's all we're doing. Transpose to make r the subject of the formula, and you find the value. That's all you're doing now. Okay. Anybody tell me what value they get for r? Can anybody tell me the value? What is the value of the radius? Going once, going twice.
Miss, I don't think I understand this. Or
Okay.
it's
Which
look
part?
confusing. It's look confusing. Miss.
From which part?
From the green, the light green part. Then
Okay. So you understand why? Do you understand
I
why
understand. Yeah, I
on
understand.
this green part?
Yeah, I
Okay.
understand.
It's the white part then.
Yeah.
Okay. So we're trying to find the value of r. How exactly are we going to do that? Well, we know we need r by itself, right? That's the only way we can find the value of r. Transposing, aka making r the subject of the formula. We need r by itself. But how exactly do we do that? Well, I see a 2r plus r times pi on 6. I would say, okay, these two terms have r in common. So I could take out r, and I would remain with 2 plus pi on 6. Why? Because if I expand these brackets, right, I'll get r by 2, which is 2r, and r by pi on 6 is r multiplied by pi on 6, right? So all I did was factor out the r, because I want to find r. I want r by itself, right? So all I did was factor out the r from these two twos.
Oh, I see it now. I see it now. I see.
Then, like I said, I want r by itself because I want to find the value of r. So what would you do? To get r by itself, I need to get rid of this 2 plus pi on 6. So I would divide both sides by 2 plus pi on 6. So r is equal to 5 on 6 by 12 plus pi divided by 2 plus pi on 6. You good with that? Everybody?
Yes, miss, I understand now.
Yes, miss.
Yeah.
Okay. What I was asking you for is the value. Of course, we can't leave it like this. So all you have to do is put it into a calculator now and tell me the value of that. Okay, let me just tell you. It's 5. Anybody not guessing 5?
I'm adding it now, miss. I'll let you know what I get.
You didn't get 5?
No, miss, I'm adding it now. Like, put it into my calculator now.
Oh, okay. So I just erase it inside. Like if you didn't want to put that, if this seems a little complicated to put into your calculator, and you could make like a single fraction. Let me show you real quick.
Yes,
You
miss, I
don't.
got 5.
Okay.
Wait,
If
I get, I got 12 point,
well,
12.0. How you get that?
so if you don't want to put this into your calculator, it's a complicated thing, which
Let
is
me check.
probably the reason why you didn't get 5. You probably put this into your calculator wrong, like you forgot brackets or something like that, right? If you don't want to do that, you could make a single fraction. So what do I mean by that? If I expand these brackets, right? So 516 times 12, that's going to give me 12 by 5 is 10.
16.14.
If I expand these brackets, 516 times 12 is going to give me 10. Because 5 times 12 is 60, and 60 divided by 6 is 10. Plus 5 times 6 by pi. I can write that as 5 pi and 6. But like I said, if you don't want to leave it like this, make a single fraction. So LCM is 6, 16 plus 6. So this is my numerator. My denominator, if I want to make a single fraction, also 6. So this is 2 plus pi. Let me just show that this is n for numerator. So this is my numerator. This is my denominator. So let me just erase. Can I erase this white part real quick? Can I erase
Yes,
this?
yes, miss.
So notice, this is my numerator. This is my denominator, right? So if you didn't want to put that whole complicated looking thing into a calculator, and by doing that, you might, risk putting it in wrong and getting a different value. Make a single fraction or single fractions. So my numerator, use a different color, is this 60 plus 5, 5 and 6. And then this is divided by this single fraction. However, we know when dividing by fractions, we multiply by their reciprocal. The reciprocal of 2 plus pi on 6 is going to give me 6 on 2 plus pi. This would cancel. And now you have something that's more simple to put into your calculator. And you reduce the risk of putting something that's wrong. I mean, getting a wrong answer. 2 plus. Everybody understand what I just said? Like, if you don't understand, please. I just simplified what I had in the white so that it would be easier for me to put it into my calculator to find the value. That's all I did. Troy, it was Troy. Are you guessing the 5 now?
Oh,
Oh, wait,
wait.
hold on. That might be a mistake on my end.
He knows. He
Because
knows
now
that you understand this. Miss,
hold on.
Chris,
Yeah,
that I don't understand this.
I think that might be a mistake on my end because now I'm not getting 5. That's the problem. Okay, let me just check this over real quick. Because now I am not getting 5. 5
don't know how you get it.
5, 4, and 6, 5, 12. And in total. Right.
May 6 more, may second like.
Oh, and I got the 5. Anyways, I got the 5. This is very interesting. Okay, let me just erase this real quick. People who have another class now or need to leave now, you go ahead. Let me just figure this out.
After what? 7.
Oh, what class is that?
POB. Then I have math at 8 o'clock.
I simplified wrong just now because here I had 2, but it's actually 12. I had 2 before, but it's 12. That's times 6. So if you put this into your calculator, you can get 5. If you put this into your calculator, you can get 5. If you put this into your calculator. The only reason I simplified it, so it's easier to punch it into my calculator, and I reduce the risk of, putting in the wrong thing and getting the wrong value. So yes, the answer is 5. Now, who did not get 5? You?
Wait. I keep on getting the wrong answer. Wait. 60.
What mode is your calculator in?
Oh,
What?
60 divided by 12 and 5. Yeah, I get 5. I work out
Okay.
on my head. I never use a calculator. I rather
You-
use.
Hold on.
Wait.
You worked out a value with pi in it in your head.
Wait.
Pi is an irrational number. How is that possible to work it out?
May 6 you cancel it out.
No.
5.
Okay, that's the lesson for another class. That is, you see, canceling these pies, not possible. Canceling 6 and 12, not possible. Okay? But that's for another class. Yeah. Because I'm
Five.
already time.
Yeah, I plugged the third one in, like the one above equals 5, and I got 5 as well.
Wait, in degree, right? Or radian?
Radian.
Radian, or wait, it's 3.14.
Okay.
So, wait, let me write it down. 75.
Hey, where's that equating, boss?
12 plus 3.14.
Right. What I was gonna say is, it matters for you to put your calculator in radian mode when you're using.
Oh,
the trig
yes, miss,
function.
I got 5.
Okay, good. When you're using the trig function, that's when it's important to put your calculator in radian mode. But you see now, we're not using any trig functions. You don't have to put it in radian mode, right? But like I told you, once you see a question with radians in it, just keep your calculator in radian mode, please. Don't risk it, right? Just leave your calculator in radian mode, and then you could put it back in degrees. Okay. After all of that, I just found out that my radius is equal to 5. Now I can find my area. Area is equal to a half. Okay, area is equal to a half r squared theta. Theta is pi and 6. R, we just found out is 5. All I need to do is substitute my values. I get my area. That's a half by 25. Why 25? 5 squared is 25. 25 times pi on 6. Okay. Answer. Anybody? I can write this. You can put this into your calculator. Anybody has an answer for me?
6.54.
6.54. That is the answer. 6.54. Don't forget your units, cm squared. That's the answer for this question. Everybody good?
Oh, yes, yes.
Okay, that's one person. What about the others?
Yes, miss.
All right. Okay, one more person. You good? Or you know? Just one more person. Just to say yes or no. Okay. All right. So we did this, we did this, we did this, and what was the other one we did? Oop, this, and this. Right. The reason why I didn't do these other questions, this. Like I said, they literally repeat every single time. I don't mean the exact values and not the exact question, but you see that, finding the area of the shaded region, it just repeats. You just have to follow the same method with different values. That's it. That's why I did 2013. 2013 was the only one that was different from the others. You would see a similar question, Actually, no, 2013 was the only one that was different from all these. See all of these? From 2012 all the way down to 2019. It's the same thing you're doing over and over again, just with different values. That's why I was paying attention to 2013 and making sure that you got out 2012, 2015, right? So you can do the others. I would actually, okay, let me record this.